Hi, this is Sean Guerre. I'm Executive Director with the Energy Drone and Robotics Coalition. We're excited to do an executive Q&A today with Stefan, who's CEO of Emesent. We're going to be talking about autonomy technology for industrial drones. Howdy, Stefan. Excited to work with you today.
Thanks, Sean. Great to be here. And yeah, really excited to give you some insights in drone autonomy and what we've been doing in that space.
Excellent. So one of the things we always love to start off with is, can you give us a bit of background on your company and your role at the company?
Yeah, sure. So as you mentioned, I'm CEO and co-founder. So I have a co-founder, Fred Kundul, who's my CTO. And together we were previously in CSIRO, which is Australia's national research lab, doing research on autonomous drones. I was there for more than 13 years. And then we developed some really capable technology which allowed drones to navigate GPS denied environments and map, and saw the commercial potential for this technology. So we formed Emesent to commercialize this technology, which is called HoverMap. So our company's basically grown from fairly small beginnings to more than 80 people now. And we have expertise in drone autonomy, obviously, data analytics, machine learning. And we're basically a robotics company focusing on capturing autonomous insights in very challenging and hard to reach areas for industry, and using that through, we're doing that through robotics.
Kind of switching more in depth to your solutions, looking at HoverMap. I mean, when you look at autonomy and technology, which we hear all the time, at Energy Drone or Robotics Coalition, what does that really mean today? Where are we on autonomous and drones and robotics?
Obviously, there's a scale of levels of autonomy, and that's been fairly well sort of described and used in the autonomous driving market. So if you go from level 0 in the driving space is you're fully in control of the vehicle, all the way up to level 5, where the vehicle doesn't need a driver at all. It'll get itself from A to B in any environment, in any scenario. So they kind of are analogies in the drone space. Level 0 would be pilot is fully in control of the drone, always on the sticks, keeping the drone safe, all the way through to fully autonomous drone where there's no pilot needed at all and it can always complete a mission. So there are progressions along the way, and at the upper end there's probably no limit to the level of autonomy, because you can always try and kind of match what a human would be able to do. So today we are seeing systems in the upper levels of autonomy, around level 3, level 4, including what we're doing at Emesent, where a pilot is not needed for an entire mission, but those are for very quite specific mission scenarios.
So thinking within tech, but moving in a little bit different direction, talk a little bit, I think we should discuss collision avoidance. It's becoming a big trend we're seeing throughout the industry, especially those who have critical infrastructure. When something's happening, being mapped or inspected, how are you solving around collision avoidance?
So for us in particular, we use LiDAR for collision avoidance. So I should have mentioned up front that HoverMap is a LiDAR-based payload. So we use a LiDAR up front, and we actually rotate the LiDAR to give a full spherical field of view. Typically, if the LiDAR is just mounted in a static position, you'd get either a horizontal or a vertical field of view, depending on how it's mounted. But by rotating that, we provide a full spherical field of view. So we are building an obstacle map in real time using the LiDAR data. And we're also running real-time SLAM algorithm on that data to estimate the state of the drone. So that's the position and velocity. And that's how we manage to navigate without GPS. So we're using the LiDAR data to generate an obstacle map, and then obviously to navigate. So yeah, I mean, collision avoidance is critical if you're flying close to anything, to structures. It allows you to fly in a way that maintains a minimum safety distance or standoff distance. With our system, you can change that safety distance in real time, and actually change the shape of it. So if you sort of need to imagine a virtual bubble or ellipse formed around the drone, and if you want to have more clearance to the sides, then from the top, you can adjust that in real time to get you in closer to infrastructure. And then once you get in close, yeah, it allows you to capture imagery at sort of high resolution without needing very high or sophisticated optics, because you can get up close and use a lighter weight camera to still capture that kind of imagery. And from a LiDAR data perspective, the closer you are to a feature, the better precision you can get from your LiDAR. So it also helps to get in close with the LiDAR. Yeah, and many assets, you know, there are restrictions on how close you can actually legally fly to them. So being able to guarantee that you're not going to get within 5 or 10 meters of whatever the asset is, depending on, you know, whether it's a cell phone tower or transmission tower, is critical. And being able to do that in all directions is also critical, because obviously, you know, a drone can move in any direction. And from an operator's perspective, if you're flying up alongside a tower, it's very hard to judge that standoff distance just visually, especially if you're sort of the asset is a long way away, or if you're underneath a bridge or anything like that. It's really hard to judge that standoff distance.
So if I think about, you talked about the richness of the visual data. So we definitely want to loop back to this. Now, y'all recently launched colorization for hover map. What can you share with us about that solution and its benefits?
Yeah, so as I mentioned, hover map is primarily a LiDAR based device. So we're using the LiDAR for navigation and mapping. So what is produced is a LiDAR point cloud at the end of the day. LiDAR by itself doesn't have natural RGB color associated with it. It does have intensity value, so you can false color a LiDAR point cloud to get context. But it's also very useful to be able to add sort of natural color as well. So how we solve that problem is by capturing video at the same time as the LiDAR. And that's through a bolt-on or plug-on accessory just based on a GoPro. The trick there is making sure that you know exactly where the camera is pointing relative to the LiDAR, right? Because you're going to project the camera information onto the LiDAR. So we have a very sophisticated calibration routine, which we run the camera and the LiDAR together to get that sort of intrinsic and extrinsic calibration. And then it's just a matter of the post-processing. So as you do the post-processing, it's projecting the color information onto the point cloud, allowing you to visualize that with true color. And that's useful for a couple of reasons. I mean, some people are just, it's easier for them to understand point clouds if they've got natural color, if you're not used to looking at point clouds all day. And then also there's sort of, if for example, if you're doing any kind of classification and looking for certain things in the point cloud, that you can use color as one of the aspects of the classification. So if you're looking for all the red pipework in a building, for example, you can use the color to help detect that pipework. In the underground mining context, you know, that there's instances where they can use the color for mineralogy, for example, as well. So it does have benefits, but it also makes the point clouds much easier to visualize and kind of understand.
Got it. Well, I really appreciate your time today, Stefan. It was great to have a chance to connect with you and learn all about the great technologies that y'all are producing and the solutions for the industrial space, and look forward to exploring it more in the future again.
Great. Thanks, Sean. Really enjoyed it. Cheers.
Thank you. Cheers. Take care now.